Welcome to Dr. Teddy's channel. This channel is designed to share my learning experience. Today, I will talk about math. Math is too broad to start. This is why I add a subtitle here. I only talk about what I know about math. I'm not a mathematician, therefore I cannot cover all math branches. The purpose of sharing my math knowledge is to help kids and teenagers to be motivated to learn math and prepare for college. Three objectives are in this video. The first one is to share my understanding on math and the relationship of math branches. The second one is to explain why I think math is hard. The last one is to demonstrate applications of math in a few cases. So everyone knows math, however, most of us are struggling with math, including me. We all know there are many branches in math. On this left panel, I made the chart to show you some of math branches that I think we should know before college. I'm sure this is not all math branches. It is too complicated to go through all of them. However, we need to know these 5 main branches. The first one, and also the most fundamental one, arithmetic, the study of numbers and their operations. The next one is algebra, the study of generalization of arithmetic operations. The next branch is calculus that studies continuous change. The fourth branch is geometry, which studies shapes. The last one is statistics that study large body of numbers. There are many branches in math. Are they connected to each other? The answer is yes. And they are intimately connected to each other, as you can tell from these arrows. I made this chart to summarize their relationships. Obviously, this is a very simplified version. It looks like a cupcake, isn't it? When you go to the elementary school, you start from arithmetic. You learn numbers and their operations. With enough arithmetic skills, you start to learn basic shapes like lines, angles, triangles, and basic statistic concepts such as means, standard deviations. By the time you go to the middle school, you start learning algebra, and you use variables to replace numbers. With the new skills from algebra, you are able to learn more advanced geometry and statistics. It is also at the middle school that you are able to apply algebra concepts in some natural science disciplines such as physics, chemistry, biology, and etc. When you move to the high school, you learn calculus, which enables you to explore more advanced geometry, statistics, science, engineering, and economics. Having a concrete math training before your college, which can make your college life more enjoyable and productive. With these so many error lines, you can tell they are intimately connected. This is one of the reasons that math is hard. I feel there were another 2 overlooked transitions which should be attributed to the difficulty in learning math. The first transition we need to face is from arithmetic to algebra. The key of this transition is the idea of generalization, which is a process from concrete to abstract. We are so used to the left panel, and we can generalize additions using a plus b equals c. We can generalize multiplication using a times b equals to c. We can generalize the last group of equations using kx plus b equals to y. In algebra, we use letters to replace numbers or variables. Equations and functions are 2 important concepts to master. We need to encourage kids to apply those algebra concepts to those word problems we used to solve with arithmetic. These examples are given right here. This is the second transition. Once we master algebra such as y equal kx plus b and y equal ax squared plus bx plus c, we can further generalize them to y equal fx. we should be able to generalize things at different levels. In this transition to calculus, the key idea is cutting down and adding up. In calculus, we introduce a tiny change delta x to a continuous function fx. We will have y plus delta y as the output. After the rearrangement, we can have delta y over delta x. We can apply a calculus concept limit, which is a new concept, to delta y over delta x. Now, you have the second calculus concept, the first derivative of fx. You can call it y prime or f prime x. Knowing the derivative is critical for calculating integral, which is a way to find out the area under curve. On the right panel, we can apply calculus to a simple word problem on the previous slide. The first step is to define a function. The second step is to solve integral of the previous function. The last step is to calculate integration. This is the end of the second section of this video. I want to bring these two overlooked transitions to your awareness, which may help you learn math more efficiently. In my opinion, arithmetic, algebra, and calculus, AAC, is the core math. They are foundation of geometry and statistics. This slide shows you how AAC can be used to solve the same problem of the circle area. In arithmetic, we use numbers only. In algebra, we use formula. In calculus, we use the three-step way to get the area under curve of a quarter of the circle. First, we need to define the function of the circle. Then we solve the integral of the function. The last step is to calculate the integration with the range, which is from 0 to half pi in this case. Finally, we have the area of a quarter of the circle. The next example is showing you how AAC is applied to statistics. In the left top corner, this is the way you calculate the mean value of a group of numbers in your elementary school. When you are in the high school, you are expected to use a generalized way or an algebra way to calculate the mean value. We know calculus is a powerful tool to calculate area under curve, AUC. On the right panel, this is a normal distribution curve, which is very popular in statistics. You can apply calculus to calculate area under curve, AUC. AUC can be used to calculate confidence intervals such as 68% confidence interval, 95% confidence interval, and 99.7% confidence interval. The confidence intervals are very useful in analyzing and quantifying uncertainty and risk. You can use the risk analysis to help your parents or grandparents' investment in the stock market. In the following slides, I'm going to show you a few cases I prepared to demonstrate the application of math in different STEM subjects. We start from another very well-known distribution, which is Maxwell-Boltzmann distribution. It is so boring to talk about this distribution only. But what if I tell you this distribution can guide us to find a way to convert graphite to diamond? Are you interested in hearing? At least my kids were very interested to hear after I tell them this. The distribution was first used in ideal gases. An ideal gas is a theoretical model with a few assumptions. Look at this distribution in this corner. The x-axis of the distribution is the energy of the gas molecule, and the y-axis of the distribution is the population of the gas molecule at different energy levels. The blue, red, and green curves can be used for different temperature from low temperature to high temperature, or if this is for the same temperature, these different curves can be used for different molecules from heavy molecules to light molecules. So in this panel, this is a simulation show you the distribution. In the right bottom panel here is a simulation show you the distribution of a gas in this box, after the equilibrium, the histogram of molecule population versus energy levels fit Boltzmann distribution very well. So you can see after the equilibrium, this histogram fit this Boltzmann distribution very well. Do you agree? With this introduction, let's see how we can use it to help us to find the directions to convert graphite to diamond. We all love diamonds. Do you know the difference between graphite and diamond chemically? Actually, they are all carbon elements, but they have different structures. Can we convert graphite to diamond? This is a very interesting question, but actually the answer is yes, we can. From graphite to diamond, we need to overcome an activation energy. In this Boltzmann distribution profile, EA, EA1 and EA2 are two different activation energy. If carbon molecules pass the EA energy barrier and go to the shaded area, they are diamond. Let's only focus on EA2 now, which is the condition without any catalyst. The shaded area and T2 profile is larger than that area under T1 profile. We know T2 is the higher temperature. Therefore, high temperature is preferred for this conversion. The other direction is to use a catalyst. If you use an effective catalyst, the activation barrier will be lower or moved from EA2 to EA1, which leads to more carbon population in this shaded area. Therefore, two preferred conditions for this conversion is high temperature and an effective catalyst. In geometry, we learn all these different shapes. In chemistry, biochemistry, and virology, there is a great interest of determining structure of molecules, proteins, and viruses. If we know the structure and we know the activity according to the structure-activity relationship, SAR, after we know the activity, we may be able to design some drugs to harness the activity, which may lead to some life-saving medicines. This is an application in chemical engineering. Chromatography is a way to separate chemicals or proteins or other biologics. From one side of chromatography, we load a mixture, and after separation in this chromatography, and on the other side, we collect purified samples. Math can help to optimize the separation. We know after the sample is loaded to the chromatography, a few fluid dynamics and chemical events happened in this chromatography, such as convection, dispersion, film mass transfer, pore distribution, and adsorption. We are interested in concentration as a function of time. We can use math equations to describe these events and build a relationship between the concentration and time. The equation is a partial differential equation. We rely on computers to solve the equation using a finite element method. The idea of the finite element method is to divide the chromatography into tiny cubic pieces. Once the calculation is done, we can find ways to improve the separation. This in silicon method can save a lot of time and money since it can replace a lot of lab work, which is time consuming and very expensive. Very similar idea can be used in predicting weather. The first step is to describe the weather change using mathematical equations, usually partial differential equations, PDEs. The second step is to apply finite element method to solve those PDEs. The last step is to predict the weather using the simulated result. In the last case, I'm going to show you a statistic simulation called Monte Carlo simulation. We use math to explicitly describe problems around us. In real life, we face uncertainties in inputs of our math models. For example, the stock price. No one can tell what's the stock price tomorrow. These uncertainties can cause risks. Mathematically, there is ways to handle this uncertainty and randomness. Monte Carlo simulation is one of these ways. In the simulation, we first define the math model and identify the uncertainty of the inputs. The second step is to generate a large number of values, let's say 10,000 or even more values, for these uncertain variables under a meaningful distribution, either normal distribution or other distributions such as triangle distribution. The last step is to analyze the large number of outputs. This method can be used to analyze people's retirement investment. It also has wide applications in other fields. Hopefully by now you are convinced that math is a very important tool for all STEM subjects, and you have enough motivation to learn math. I will make some math videos. I'm trying to focus on two things in my video series. The first one is to focus on the systematic connection of different math branches. The second one is to focus on helping students to transit from one branch to another branch smoothly, especially from arithmetic to algebra and from algebra to calculus. I hope this video will be helpful to you. Stay tuned. Alright, this is the end of this video. Thank you very much for your time. If you like this video, please like and subscribe this video. If you want to be posted, please click the bell icon. You are welcome to leave your comments below this video. Thank you again.